Hello YouTubers, welcome back. This is episode 4 of MIG welding. Once again, this is not a very formal class in welding. It's just covering some things, some tips and tricks as I go along. They'll come to me, and so this is more of just a if you can get something out of it, that's great. If not, just have fun, enjoy the video. I guarantee to be entertaining in one way or another. So just thought I'd go over what a weld ought to look like, because if you're welding something, let's say you're welding this piece to this piece in thin material, what you need to do is make sure that when you weld this, that it's hot enough to penetrate down into the weld joint. So if it's 1/8 thick, I mean, you don't bevel anything under 1/4 inch really. You just make sure you got a good enough gap. Even 1/4 inch you can do it if you're good, but make sure you got the gap just right to get that one weld down in there, and you won't see much at the bottom, it'd be just a little bit there, but it's not truly a good weld unless it goes right through. It's really only half of a weld, if it comes up a little bit short under there. In which case, ideally you run a pass on the back, just to be on the safe side. This is called reinforcement, and this is called your base metal. This is your weld, obviously. When you grind a weld off, you're actually making this whole area weaker than the original. If you leave that weld, as long as it's got a great looking profile, you really should leave the weld. That's why you quite often see welds. People don't clean them up because, if you're an amateur, you think, well, I should grind all that stuff down and make it real pretty. Well, you're doing yourself a disservice, because you're making the overall joint a little too weak. It's, it's close to the original, but it's not 100% as strong, because you have a what's called a heat affected zone all in here, where the metal has been affected by the heat, and that's pretty obvious, I guess. But so this is kind of like insurance, this stuff, this extra bit of metal. So try to do a really pretty weld, and then you can leave it there and you can be proud of your weld. So a weld profile for a fillet joint, say you ran another piece in here. Now, in small material, it's not a problem to just butt that right up. There wouldn't be a gap. You just bang it right up against it, and you're going to do a weld here, and you're going to do a weld here. I'm just going to exaggerate what the weld should look like so you can see it a little clearer, but it wouldn't be this big. But the profile, like a cross-section look, should be like this. Okay. It should be slightly humped up in the middle, and this is what they call a wetting in, which means it's a smooth transition into the base metal. What's called undercut is when you've ran this a little too hot and it melted that away and left, if you've done a bit of welding, as an amateur, you'll understand what undercut is. That's where you ran it pretty hot and you didn't have the angle of the gun quite right, or there's a variety of different reasons for getting undercut, but undercut is a serious problem, because you've just taken this, let's just say this was 1/4 inch and you had a decent undercut there. Well, you just turned that 1/4 inch into 3/16. So what was the point of building the whole thing out of 1/4 inch anyway, because it's really only going to be as strong as that weakest point. So you really want to try to control undercut. If you get undercut, the simplest way to fix it is to run another little quick pass in there. It's not going to bother anybody. It's you're kind of doing a little bit too much work there, but it's better than having that weak spot. So don't do it. Set your machine right, and practice. What I'm going to do right now is I'm going to show you a little bit of welding on some 1/8 square tubing, just because that was the first thing I grabbed, a piece of scrap. I turned my machine down to where that would be. Ideally, let's just put her around 19, just as a starting point. What I've got here is 2 pieces of 2-inch by 1/8 wall square tube. It's called, if you're going to go buy it, you're looking for HSS. It stands for hollow structural steel. Once you get a little bit thinner than this, it goes from being called HSS to ERW, I think is what it's called. It's electronically resisted welded. It's sort of cold rolled and then welded, and it'll have a shiny appearance. It won't have a scale coating on it like most large tubes. So let's see. If you were actually building something and you're trying to do a nice joint like that, a good square to use. I mean, you can use pretty much any kind of square. Speed squares aren't bad. Any kind of framing square is okay. They tend to be kind of big, so big square, big project. But one thing you want to do is nip the corner off carefully. Don't add a bunch of heat to it because you may throw your square out a little bit. But one real easy trick, if you ever have a square can be fixed quite easily. Let's say this thing fell and this square I'm going to put it on the table here to show you. If this square fell on the ground and this got bent in, all you've got to do is actually quite easy. Right in here, take a center punch and give it a little center dab right there. What that'll do will, in a very small way, push this way. If it's not quite enough, do another one just behind it. You may have to put 3 or 4 in there. Just work your way along until this thing is back to square. That only applies if it bent in this area, which usually it does. If it's bowed in, you'll have to find where it's bent, and then that's where you want to put your center punch. That's what it does, is it pushes that metal out, and because it's got nowhere to go, it just puts it right back. So there's a little tip for you, how to repair a square. How to check a square, pretty simple. You'd be surprised how many people don't know this. But it's pretty simple to check. Find yourself something real square. This is not really the best thing for it, but put it up against something that's square and make yourself a mark, right? And then just flip your square and check it up against the other thing. You know, as long as that's a straight edge along here. Then if that's a good square, then those two lines will be perfectly perpendicular. If they're out a little bit, then you know you got to do some work on your square. So I'm going to put that back. This is for small stuff, tubing and stuff. This is sort of the general shop square that lots of people use. Tri-square is what it's called. Works good for lots of tubing and stuff because you can put it up against the back here. You know, fits in smaller spaces than a speed square or a framing square. And it's used for probably 90% of the squaring work, except for larger things, larger square. I'm just going to cut this off now because it's going on 8 minutes, and pick up at the next session here. So hang in there.